Okay, so this question is about calculating an area of a shaded region. Specifically, these are called composite figures, which means you're usually taking either some figure and adding another figure to it, or some figure and subtracting figures from it. In this case, we have this large outer figure, in which case is going to be a square. And our goal is to somehow take out these triangles right here, so that we're just left over with this strip of space in the middle, in the walkway. So let's go ahead and look through the word problem and pick out some important information. It takes 24 feet of fence to surround this square piece of land. So there's 24 feet of fence making up this whole outside, this perimeter of the square. Linda wants to plant flowers everywhere but on the diagonal sidewalk, the shaded region. Note there is 1 foot of sidewalk along the two sides of the squares indicated in the diagram below. What is the area of the sidewalk? So the first goal is going to be find the area of the square itself. And that'll give us like a giant shaded region, which I'll put in blue here. Once we find that, we're going to be getting this whole entire section. However, our next goal will be to take out these regions that I highlighted before. And those are going to be triangles. So we're going to need the area of 2 separate triangles. And once we find all 3 of those areas, we're going to take the square and we're going to subtract each triangle individually. So to start with, the square. Okay, so the area of a square, you're going to need a side squared, or you can call it length times width, because a rectangle formula would also work here. And so we need to know what is the length of the square, what's the width of the square. The nice part about a square is all the sides are the same. So if it takes 24 feet of fence to go all the way around the entire square, we can cut that by 4, or divide by 4, and get that each side itself is going to be 6 units per side. Alright, so we have the area of the square is going to be 6 times 6. Each side is 6 units. And we end up with 36. Now we need to find the area of each little triangle. So now that we know each side is 6 units, this triangle right here that I'm highlighting, the bottom one, is only 5 units by 5 units, because we're taking a foot off of each side. So the area of a triangle is 1/2 base times height. It's basically half of a rectangle. Any rectangle you draw, you can make a triangle out of that. And it's always going to be half the size of that rectangle. And it's important to note that your base and your height always need to be perpendicular to one another, meaning they are going to intersect at a 90-degree angle. If they are not, then you need to find a height that is perpendicular to your base. In this case, they are perpendicular because the square has intersections that are 90 degrees. So we have area is 1/2 5 times 5, which is going to be 12.5 feet squared. All of these are going to be feet squared. Area is square units. The area of the bigger triangle is going to be a base of 6 and a height of 6. So this one's going to be 1/2 6 times 6, which is going to be 18 feet squared. So now that we have all our areas, what we need to do is put them all together. The area of the shaded figure is going to be whatever the square is minus each triangle. So we have 36 units minus 18 units minus 12.5 units. And we end up with 5.5, and the unit here is feet squared. And if you're not sure where that feet squared came from, let's go back and kind of just look at this square one more time. It's 6 feet times 6 feet. So not only are you multiplying the numbers together to get 36, but you're also multiplying the units together to get feet squared. Feet times feet squared. And that's all for this problem. It was option B.